Good morning, friends. In this video lecture, let us discuss more about the aerodynamic center. Particularly, we'll discuss a problem on the aerodynamic center based on the derivation we did in the earlier class. So, in the previous class, we have done the derivation, that is, for finding the aerodynamic center, we have got the relationship. That is nothing but XAC by C equal to minus dcm by d alpha by dcl by d alpha. So this also we have taken as the minus m naught by a naught. So we need to find out the this relationship, that means this ratio, also this ratio. So once we get this ratios, then we will be able to find out what is the aerodynamic center with respect to these values. So first of all, we all know that for finding, that means if it is in the differentiation, so it is nothing but the difference in values. So in the numerical calculation, we can take it as the difference in values between two limits. So that we can apply here also. And before that, let me just give the problem. This problem based on the NACA aerofoil, NACA 2412 aerofoil. This data has been taken from the theory of wing section. So from the theory of wing section book, by about and one DNO. So from this book we have taken the data for for a interval, that means between two limits, what is the value of CL and also what is the value of CM, that means pitching moment at a quarter chord point. So now for this value dCl by d alpha, dCl by d alpha, for finding this value, let us consider at minus 8 degree. So because we need to take the values between two intervals, that means this is starting value, one value, and then at plus 8 degree. So we can take any values because it is the difference. So any value can be taken. So those values we can say as the at 8 degree, minus 8 degree, it is nothing but CL value is nothing but CL is minus 0.6. This is 0.6, and this value is nothing but 1.08. So these are the values given from this theory of wing section, okay, by Abbott and Von Neumann. So we got these values, and then based on this we can find out the dCl by d alpha. So dCl by d alpha, we nothing but dCl by d alpha, nothing but that is the difference, that means we have taken the limit, that is starting value, ending value 1.08 minus of minus, because this value is minus 0.6 divided by this with respect to this value, what is the angle of attack, that is 8 degree, minus then minus of this is minus 8 degree. So based on this we can do the calculation. After doing the calculation, this value comes around 0.105. So dCl by d alpha we got it, that is nothing but 0.105, and then we can find out the in the similar fashion, that means for dCl by dcm by dcm cm alpha by d alpha. So this value also can be found out. So we can take this is at minus 8 degree, and this value need not to be same. That means we can have a other value also. Minus, instead of 8 degree we can have it 10 degree. So it is 10 degree. So 10 degree, what is the cm value? That means here we need to find out this. Cm is L04. So this value we need to find out at 8 degree, and here also Cm. So this value we need to find out at 10 degree. So at minus 8 degree, this value comes around 0. Minus 0.045. So and then this value comes around, this value is minus 0.035. So this is the value, and so we know just at both the angle of attack what is the value of pitching moment at a quarter chord point. So now we can find out what is this value. This value can be found out. So we can just say this as nothing but this can be written. So we know that this is nothing but, so this we can write as the starting value. So a difference, so that is a difference between these two values, that is what this. So minus 10 degree, 10 degree minus 8 degree. So we can take minus 0.035 minus of minus 0.045. Okay, so then whole divided by this angle. The angle is 10 degree. It is 10 minus minus of 10 degree minus of minus 8. So this is, so this, after doing this calculation we got the value around 5.56. This value is nothing but 5.56. We can say nothing 0.00 is 5.56. We can just straight away we can write 5.56 into 10 to the power minus 4. So this is the value we are getting for this, and for the DCL we got 0.104. So we got those values, not 104, it is I think 105. Yeah. So we got both the values, and now we can substitute in this formula. So that means so after substituting these values, so then we will get XAC by C equal to, yes, minus sign is there, it is not taken away. So minus sign is there, minus 0.00053. Okay, so this is the value we are getting from the calculation. So after just substituting and after finding dCm by d, this value, and dCl by d alpha, after finding and substituting, then our aerodynamic center becomes this. So that means this value is ahead of the quarter chord point. That is the idea. That means, so we have our location. Our location we said it is nothing but, so it is, so because our location. So if this is the quarter chord point, so we just quarter chord point this is. Then our aerodynamic center was here. So this is nothing but XAC. So now this value becomes negative. It means this value is ahead of the this, because if this value is behind the quarter chord point, that value we have taken as positive. Since okay, it is negative, then this value will be somewhere here. This value will be here. That's a point. That means this aerodynamic center ahead of the quarter chord point. Okay. So or we can say forward of the quarter chord point. So that means this value nothing but we can say our finally if you want to calculate XAC. So XAC by C is nothing but because this is a quarter chord point, 0.25 minus this value has to be subtracted. So 0.0053. Then after doing this one, how much we are getting? So it will become XAC by C equal to 0.2447. So this is the value we are getting. So that means our aerodynamic center is located 24 point or 0.2447 times of the C. That means XAC is nothing but further we can write XAC is nothing but 0.424 that means we are just doing the cross multiplication 0.2447 into C. So this is nothing but chord. So in terms of percentage, 24.47 percentage of the chord. Okay, our aerodynamic center is located. So that is a location. So this is how this problem has been solved. So if you want to have a more clarification, that means how we are getting these values. So our value how we are getting, so that nothing but in the book, theory of wing section book, if you see this value will be given. So that means this is CL. For finding CL I am just giving the idea. So this will be the alpha. So we have taken minus 8 degree. So minus 8 degree here and plus 8 degree here. So that is how we have taken the limit between minus 8 and plus 8. We have taken the values for finding the DCL by D alpha. So from this, that means by using this graph, so this graph might be something like this. So based on this, so that means not like this. Okay, we have got the graph is not, it was not like this, it is something different. That means something we have added something like this. So like this in this graph, okay, we got the value, what is the this value and this value, something like this. So this is we go for this help us to find out DCL by D alpha from the theory of wing section book. So because it is this is positive and this is negative. Okay, so this we got it, and then similarly the DCM by quarter chord point, that also has been given. So here it is given as the angle of attack. So angle of attack is given here, and here section lift coefficient. In this vertical axis, this has been mentioned as the section lift coefficient. Similarly, for the DCM at quarter chord point by D alpha, that value we have calculated from this graph. That means by using this graph we have found out. That means this is the graph means it has not been given as the reference, so we can take it as the reference 0. That is this is a 0, and here is the movement coefficient is given. So they mentioned as the movement coefficient in this vertical axis. They mentioned movement coefficient moment coefficient, and also particularly at CM C4. So this they mentioned, that means CM C4. So this is mentioned in the vertical axis, and in the horizontal axis, as usual, it is the angle of attack. So angle of attack is given. So that means especially section angle of attack. So that should be clear. Section means aerofoil. So that is the idea. For this, the graph is given. That means for finding the moment coefficient at quarter chord point. So between two limits, we have taken -8. So -8 was here, and 10 degree. So plus 10 degree here. So at both the angles, we have taken the our that means moment coefficient at a quarter chord point. So that was actually like this. This might be the line pitching moment or moment coefficient distribution line was something like this. So from this only we have got the DCM at a quarter chord point divided by this d alpha. So this value we have taken. Okay, this graph helps us to find out this value, and this value we have seen in our previous graph. So this is how we got the values of these two, and finally we got the answer. So our final answer was 0 point. That means our XAC by C equal to minus 0. Sorry, yeah, minus not minus. Okay, after finding the value, it was 0.2447. Means it is ahead of the quarter chord point, nothing but forward of the quarter chord point, we can see. So I hope this lecture helps you to understand how to find out the aerodynamic center from the graph by using the data.